Morning, everybody. So I am excited to share with you our final design project for this course. You can sort of see the inspiration of this project right here, and that is the Start a Smile Challenge, which is something which was started by the Future Engineers organization. They're holding a contest for students in the US to essentially do this challenge. And I thought it was so great that I wanted to do some version of it here as the final thing that we do. That contest is only open to students in the US, but that doesn't stop us from participating. And so this is really an opportunity for you to make something similar to what I've asked you to do in the past, but with a little bit more openness maybe than you've had in the past. I've been really impressed between the cardboard challenge and the hackathon and some of the other things I've had you do, where when I give you a lot of flexibility, you come up with a lot of really great ideas. And so I want to encourage that in the final weeks of school. So here's the idea behind the challenge. The idea is that you want to design a device, an object, a machine, something that can start somebody smiling or feel appreciated during our current situation. And so the idea is that the target, the person who is interacting with your device, must be separated from whatever you design by a window, a wall, a computer screen, or a physical barrier there, or at a distance of 5 meters, so it can be actuated or interacted with from a distance. It cannot involve physically touching or exchanging items, because obviously that could contribute to transmission of the virus if it was on a physical surface. So take a look at the link that I put on Power School Learning to understand the general idea. I want you to have a lot of choices here. You can choose to target a specific person or people or age group or category. So you choose who you want to design something for. You can also choose to use any of the platforms that we've used in this course. So you could use Microbit from semester 1. You could use Metro, which we looked at in semester 2. You could use Onshape. You could learn to use Arduino. You could do all these things. Try using one of these platforms and just using it in a new way. I'm also looking for some differences in collaboration. In that if you collaborate with somebody, I want that collaboration to be because you might focus on the mechanical design or doing something in Onshape, and the other person works on something related to electronics, or if we can, potentially physically build this thing, make this thing happen. So I want you to choose an audience. Who are they? Why are you designing for them? I want you to talk about the inspiration for how your design addresses the needs of your target group. Obviously, you're going to cite any sources for material you use in putting this together. I'd like to know, what are the different levels of requirements? So what must it do first? What is its essential job? What should it be able to do in addition to that one main thing that helps it do its job? And so that might be it should look professional in terms of how everything is wired. It should be safe. It should be consistent, something like that. And finally, something nice to add. You might not need a lot of flashing lights because that maybe doesn't contribute to what your design actually does, but that could be a nice to have. And so I want you to rank those different design requirements so that you have a good idea of what your priorities are as you piece this design together. I want you to think about materials. I want you to think how you would actually put this together. Can you build it by hand, cutting out of cardboard? Do you need to 3D print? Do you need to laser cut? What electronic parts maybe do you need from the Idea Center or ordering from an online store? And have you prototyped your idea in Onshape? Can you build it in Onshape? What are your thoughts there? And I want you to have all of the information needed for someone else to build your design. So that goes everything from a parts list to a materials list to a wiring diagram. Whatever it is that you put together, I want someone else to be able to follow your instructions and make it, or at least have the resources. I want you to build a complete prototype. Very often with our projects, you basically complete one design cycle and you create a single prototype. I don't want that. I want you to make something. It's going to be messy. It's going to be not great. I want you to do a full design cycle and then think about how you can actually improve it in a way. If you make it out of cardboard and it's all jagged edges and everything. Maybe you then model pieces in Onshape and laser cut some pieces, or at least create the designs to be able to laser cut. And I want you to make that prototype and then come up with improvements from that prototype. And then finally, I want you to come up with a proposal for the final thing you're proposing. Screenshots, photos, drawings, and finally a video showing how your design functions to meet those requirements that you described were essential. The most essential requirement, the really should have requirement, and the nice to have requirement. And that's it. I am looking for this to be the one thing that we spend our time doing over the next month or so that we have left in school. So think about this, come up with some ideas, and share those ideas with me. We'll do some brainstorming and thinking about how we might go about this. But I'm really excited to give you the freedom to build something that you are interested in building. And I would like us to actually be able to make these things by the end of the year. So let's get started. Start thinking about what you might make and get to work. Thanks, everybody.